Okay, in the previous videos we looked at recurrence relations for modelling linear growth and decay. We also looked at arithmetic sequences using both recurrence relations, so where you work out every term sequentially, or recursively as it's called, or using a rule to jump to the nth term. Okay, so Tn over here. And so that's using a rule, and then doing each of these you use a recurrence relation. And when we're doing applied questions on things like simple interest, it's much easier to use a rule to work out what the values are in the future. So starting with V0 obviously over here. So T0, or in finance we use V0. So we just swap that for V and for V, meaning value. Alright, so if we recall the simple interest formula, of I equals P RT over 100. If we swap that principle for V0 now, because that's the same thing as the starting amount, you'll remember that simple interest goes up by a fixed amount every time. So, to work out the fixed amount, which is what makes it arithmetic, we need to use the rate over 100 times the principal. Okay, and that works out the common difference. And you'll remember that the rule for a arithmetic sequence is Vn is equal to V0 plus or minus n times d. Okay, so the number that we want to go into the future times the common difference. So in this case, d is the amount added on each time. So we're going to use this now for an applied question. So if we look at $4,000 invested at simple interest of 5% per annum, the amount of interest earned in the first year is, so in order to do this you need to work out that 5% of V0, so times the V0 of 4,000, gives us 200. Okay, so remember with your fractions you can move that on top there. And now that's the same formula as this one up here. And that equals 200. So that's our common difference, D, every time. Now they want to know in the first year. So the interest is equal to 200 times 1. Okay, so 200 times 1 gives us B. If we look at the next question, it's very much the same, so I won't go through that one. You can do that one yourselves. Solving with formulas. So we can use this equation to solve for any of the unknowns inside. So we can either find, as long as we got the other ones, we can find V0, or if we had, say, if we had these three, we could find N. So all you got to do is know the formula, and you can solve and find out the missing details. So a sum of money is invested in an account paying simple interest for 8% per annum. The total interest earned is for 6 years is 27,000. So what's the sum of money invested? So they're looking for V0. They've told us that I equals 27,000. They told us R is 8%. So we're going to write out our formula now with those substitutions in it. So we've got V0 is unknown, so we'll leave it like that. I is 27,000 times 8 times N. Now what's N? N is 6 over 100, and that can be solved now using your algebra solve function for V, if you just get rid of the 0 because your calculator won't know what that means. Okay, so you can solve that for V. So if I just open up the calculator now to try that, so solve 27,000 equals V times 8 times 6 over 100 comma V, and we get 5.625 times 10 to the 4, so we're going to have to move that decimal place along. So 5.625 times 10 to the 4, so let's move that 1, 2, 3 and 4 times along. So we're going to have 56250.00 dollars, which is that answer there, C. Okay, let's do this one now. So we have the amount is 6,500, so that's the V0 there. Borrowed at simple interest for that rate. The interest paid over the period of the loan is 910. So what's the period of the loan? So they're looking for n. So if you pause the video now and have a go at this one yourself. So once again, we put out the formula with the substitution. So that's our V0 is equal to, interest is 910. V0 is 6500 times rate of 3.5 times n, unknown, over 100. And once again, solve that for n. Okay, so put that in the calculator. Solve 910 equals 6500 times 3.5 times n over 100, comma n, 4. So that was obviously 4 time periods, which I think says, yep, so n equals 4, so there, 4 years. Okay, and it's pretty much the same as that for the other one, so I'm going to leave that there for you to do.